So we are given an array of length n which is sorted in ascending order, however it is rotated. So as you can see, we have got 3, 4, 5, 1 and 2. So my first element is 3 followed by 4 followed by 5, and then comes 1 and 2. So this may be the kind of graph. So we need to return the element which is minimum in value. Okay, so over here this returns 1 and over here this returns 0, since these two are minimum. Now it says we need to do this in log of n time complexity, by which binary search should strike our mind. So what we do is we have got 3 followed by 4, 5 leading to 1 and 2. So if I put the indices, so this is 1, 2, 3, 4. So I initialize something known as low. My low is initially set to 0 and my high, which is initially set to size. So my size is nums.size, which is 5. So I do my high or right as size minus 1. So this is 5. So when I calculate the mid, so my low is over here, my high is over here initially. When I calculate the mid, this will be 0 plus 5 by 2. This turns out to be 2. This is my mid. Now my nums of mid is 5. Okay. Now the important step is, if I compare my nums of mid and nums, if I compare my nums of mid and my nums of high, so what we see is this is 5 and this is 2. Since this is sorted in ascending order, it means the element on the left should be less than element on the right. Over here we have got 5 greater than 2. So we have got this element over here and this element over here. This is 5 greater than 2, which means we need to search on the right. Okay, so what we do, I put my low as mid plus 1. I do not take my low as mid, since this is 5 is greater than 2 already. In that case 5 cannot be minimum. Okay, so let's go ahead. So my low is put as mid plus 1. So this turns out to be index number 3 and my high was at index 4. So my mid turns out to be 3 and my element at mid would be 1. So let me rewrite this. So my low is at index number 3, my high is at index number 4 and my mid is at index number 3. Now I compare. So in my nums of m and nums of high, so over here my nums of m is 1 and nums of high is 2. That means 1 is less than 2. So this is a favorable condition. So what I do, I reduce my h or change my h. I change my h to mid. I don't do it mid minus 1 because mid could be an answer. So I update my h to mid. So finally I have my low as 3, my high as mid. So my mid was at index number 3. So when I get mid again, so when I compare, so my nums of m is equal to nums of high. So my new case would be, this would be low, this would be middle, and this would be high. So in this case I am able to get my answer. So then I return. So I'll solve this. So over here, my first step would be to create a mutable variable called left, another mutable variable called right, which is initialized to nums.length minus 1, and I do while my left is less than right. In that case, I put my mid as left plus right minus left by 2. Let this condition be equal. Okay, now if my nums of mid is greater than nums of right, in this case I need to go and search in my right. Okay, now I write my else if condition. My nums of mid is less than nums of right. Okay, in this case I need to put my right as mid, otherwise else I'm at the correct location. Okay, so my answer is stored in nums of mid, so I return this. Okay, and just for the sake of returning, this is an unreachable point, so maybe I say let me return left from here. Let me run this, submit.